Good afternoon, grade 12s. Welcome to our telematics broadcast for this afternoon. The final segment of our Term 3 mathematics revision will revolve around trigonometry. Now, if you notice from the monitor, trigonometry is 40 marks in paper 2, right? And in our revision booklet, it's from page 27 to page 37. There you'll find many aspects of trigonometry that are examined in mathematics paper 2. So we encourage you to really work through these very fine examples. Also, do take note that all trigonometry content from grades 10 through to 12 will be assessed in the grade 12 final examination. If we do a brief recap in connection with our grade 11 work, you've worked with the cost diagram and the various functions in connection with the Cartesian plane. We're going to talk about that in a moment. If we focus on some of the main points here, I'd invite you just to have a look here at what we see. Firstly, let's talk about negative angles. This is something that you dealt with in grade 11. The sine of minus theta, you learned, is equal to minus the sine of theta. The cosine of minus theta is equal to positive cosine theta. And the tangent of minus theta is equal to minus tan theta. These are the negative angle rules that play off in our entire approach to trigonometry. Then also, you remember from grade 11, you also learned the following. When we look at our cost diagram, remember all stations to Cape Town, right? All trigonometric ratios are positive in the first quadrant. Sine is positive in the second quadrant. All of the others are negative. That is cosine and sine. Sine is positive in the second quadrant, but cosine and tangent are negative. Here we have tangent is positive, and here we have cosine. So if we just have to put our memory aids, we have A, all stations to Cape Town. So these represent those that are positive in each quadrant. And that's why we call this a cost diagram, C-A-S-T. All are positive in the first quadrant. Only sine is positive in the second quadrant. Tangent is only positive in the third quadrant. And cosine is positive only in the fourth quadrant. That is the only one that's positive there. Now, what about our angle arrangements? In other words, when we look at these angles, notice in the first quadrant we have 90 minus theta. The second quadrant, the defining ratios there are 90 degrees plus theta, as well as 180 degrees minus theta. That means it's in the second quadrant. In the third quadrant, 180 degrees plus theta is the defining ratio. And finally, in the fourth quadrant, 360 degrees minus theta. Finally, what we just like to revise with you is a diagram in connection with our negative and positive angles. Remember, if ever we are asked to draw a diagram involving the Cartesian plane, and it's a positive angle, we need to start from the x-axis, as an example here, and draw it round this way. But if we're looking at a negative angle, well, the negative angles start from the x-axis and go down this way here. All right? And that's what we'll need for our program this afternoon. Looking back to the monitor now, our pre-grade 12 trigonometry knowledge involves special angles. We know that. We've just dealt with negative angles and cofunctions, as well as the sine, cosine, and area rule, which comes up in paper 2 under 2D and 3D trigonometry, and then general solutions as well. Now, for general solutions, you may want to remember this, that the common formulae involved for sine theta is equal to arc sine A plus K 360, or theta is equal to 180 degrees minus arc sine A plus K 360. Remember, sine is positive in the first and in the second quadrant. And we just spoke about the defining ratio of the second quadrant as being 180 degrees minus theta. What about cosine? Well, we could bring the cosine formula together by saying theta is equal to plus or minus arc cosine of A plus K 360, where K is an element of Z. And tangent, notice theta is equal to arc tan A plus K 180 degrees. Remember, the period of every tangent graph is 180 degrees only. And that's why this formula that is used for the general solution has k 180 degrees here. Whereas the period of the sine graph and the cosine graph, right? The mother sine graph and the mother cosine graph have the period at 360 degrees. Moving on, if we are asked for x being an element of minus 360 degrees and 360 degrees, what we then need to do is we need to choose integer values for k. In other words, we need to start at, say, minus 3, minus 2, minus 1, 0, 1, 2, and find out where the angles will fall in there. So, for example, if x is equal to 30 degrees plus k 120, if I had to substitute minus 3 for k, I multiply minus 3 times 120 degrees, and I add 30 to that, I'm going to get minus 330 degrees. If I take minus 2 and substitute it for k, multiply that by 120, I'm going to get a negative plus 30, I'm going to get minus 210, right? And that's what this particular slide illustrates right here. Now, on the formula sheet, the following formulae apply in paper 2. Notice, firstly, we have the sine rule. In triangle ABC, A over sine A is equal to side B over sine of angle B is equal to side C over the sine of angle C. Then we have the cosine rule that is sketched here. A squared is equal to B squared plus C squared minus 2BC cosine A. And finally, the area rule. Area of triangle ABC is equal to a half AB sine C. And of course, we can fashion this based on the triangle that we are given. In other words, if we're given triangle PQR, well, we just change these accordingly. Then in grade 12, we also learn the double angle and the compound angle formulae. Here we have the sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Moving across here to the sine of alpha minus beta. Notice we have sine of alpha cosine beta minus cosine alpha sine of beta. If you look at these two formulae, you have exactly the same concept. So where you have a plus here, you're going to put a plus between them. Where you have a minus here, you're going to put a minus between them. But for the cosine formula, things change a little bit. And we want you to watch very carefully. The cosine of alpha plus beta will be the cosine of alpha cosine of beta. That's the first change. And because there's a plus here, we must put a minus between these two. So in other words, now that we've got the cosine, we have the sine of alpha and the sine of beta. And then the cosine of alpha minus beta is equal to the cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Taking it further, we can further simplify these into what is called identities. And cosine 2 alpha, in other words, if we have cosine alpha plus alpha, could be expressed in three ways. Firstly, cosine squared alpha minus sine squared alpha, or 1 minus 2 sine squared alpha, or 2 cosine squared alpha minus 1. All these three ways represent this particular expression, cosine 2 alpha. And the sine 2 alpha identity is 2 sine alpha cosine alpha. Now, no doubt your teacher helped you derive these. They're in your textbooks, they're in your study guides. Please have a look at them. Let's work with these as we go through our program. Now, grade 12s, I mentioned at the outset that many learners find trigonometry challenging. And you know, perhaps one of the reasons why learners find trigonometry challenging is because in everything we do in maths, in fact, in everything we do in life, we need to follow a very important motto. And the motto is, plan your work, then work your plan. So I want to introduce a motto that can help you with trigonometry. The motto is SFI. If you look at the monitor, the 3-point plan of that motto, plan your work, then work your plan, for trigonometry, the S stands for simplify. The F stands for factorize. And the I stands for identities. In other words, when we get a trigonometric problem, firstly, let's see whether we can simplify it. Next, let's see whether we can factorize it. And then thirdly, let's see whether identities can help us come to a solution. So we're going to use that 3-point plan in our program this afternoon. And what we're going to do now is we're simply going to take the November 2019 paper 2. We're going to have a look at question 5, and we're going to work through this question here. Notice here, grade 12, question 5.1 says, simplify the following expression to one trigonometric term. So in other words, what this question is saying to us is that after everything we've done, we must simply have one trigonometric term. We can't have a sine x or sine theta and a cosine or a tangent. We must have one, to a single trigonometric term. What can help us? Certainly SFI. Simplify, factorize, and identities being used. Let's see how this plays off. Well, if we look at that, there we have sine of x as an opening expression, cosine divided by cosine x multiplied by tangent x, plus sine of 180 degrees plus x multiplied by cosine of 90 minus x. How does that simplify itself? There's our first S. There we have sine of x, that was in the numerator, we have cosine x. That is known in some textbooks, in many textbooks for that matter, as the quotient identity, because it involves sine x divided by cosine x, right? Division, that's why it's called the quotient identity. And so if we look at the monitor, that tan x can be simplified into sine x over cosine x. We can also say that's also the identity. So we can chop and change whichever one of the 3-point plan we are using. We can use that. This sine 180 degrees plus x, remember this is the defining angle ratio of the third quadrant. And in the third quadrant, sine is negative. That's why this becomes minus sine x. And then the co-ratio from the first quadrant, the cosine of 90 minus x from grade 10, we learned that that is simply sine x. Notice now in the denominator, this cosine x is going to cancel this cosine x. And then we're going to have sine x divided by sine x, which will bring us to 1. So the first part of the term, this simplifies to 1. And then when we multiply sine x minus sine x, we're going to have minus sine squared x. And that answer is simply cosine squared x. You may say, so where does that come from? Well, you may remember the following identity from grade 10. Sine squared theta plus cosine squared theta is equal to 1. Right? So if we have to make cosine squared theta the subject of our formula, that's going to equal 1. You take this over minus sine squared theta. And that's what we have on our screen. So if we look at the solution to this, the single trigonometric ratio that this reduces itself to is simply cosine squared x. By the way, this particular formula here, right, this identity for that matter, is the square identity. And some books even call this the Pythagorean identity because it's derived from the theorem of Pythagoras. Right? So you may recall from grade 10, you have the quotient identity, which says tan of theta is equal to sine of theta divided by cosine of theta. That's called the quotient identity. And then the Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1. That was question 5.1. Let's go now on to question 5.2. Notice the bold print that is mentioned there. It says without using a calculator. And grade 12s, we want to stress, if you use a calculator, that is what we call a breakdown. You get 0 for that. You should not use a calculator where you are told, do not use a calculator. All right? So let's go back. Question 5.2. Without using a calculator, determine the value of. If you look at this expression, the numerator, sine squared 35 degrees minus cosine squared 35 degrees over 4 sine 10 degrees cosine 10 degrees. You may be looking at this question and thinking to yourself, how on earth do I approach this? Firstly, 35 degrees is not a special angle. I know my special angle, so I can't use that. And 10 degrees is so far from a special angle, I don't know how to actually approach this. Well, grade 12s, do not despair. It's much easier than we think. Let's have a look at the monitor. When we look at the monitor, notice how we solve this. there's our opening statement. Sine squared 35 degrees minus cosine squared 35 degrees over 4 sine 10 degrees cosine 10 degrees. My first step is what I do is I take out a negative. In other words, I'm fashioning this particular expression in the numerator so that it can look like an identity. So when I take out the negative, I'm going to be left with cosine squared 35 degrees minus sine squared 35 degrees. And you may remember that that is one of our identities. Of course, not with the 35, but with the theta. And then this one here, this 4, I break it up into 2 and 2, and I simply put that in brackets. So now, as part of my 3-point plan, I am going into simplifying the S, and I'm going into identities. That's how I'm going to solve this. Well, watch carefully. So I come back here, and from this point I have 2 in the denominator, brackets 2 sine 10 degrees, cosine 10 degrees. Well, how does this simplify itself? Notice this one here. Cosine squared theta minus sine squared theta is cosine 2 theta. So in other words, this is cosine of 2 multiplied by 35. What is 2 multiplied by 35? I can hear you saying it. Yes, it's 70. So in my numerator, this simplifies to minus cosine of 70 degrees. My denominator, this here, is the same identity as the sine of 2 theta. And so there I have that 2 sine 20 degrees. But I know from grade 10 that if I have to fashion this in terms of cosine, in other words, to talk the language of the numerator, right? What I simply do is I can change that to the co-ratio, and there I have 2 cosine 70 degrees. Now look what I've got. How about that? I've got cosine 70 degrees in my numerator, and cosine 70 degrees in my denominator. These two cancel each other out. I have negative 1 divided by 2. My final solution is simply a half. And there you see it right there. Very, very easy. Let me go now on to question 5.3 that was found in the November 2019 paper 2. We were given that the cosine of 26 degrees is equal to m. Right? So that's a letter of the alphabet. And then we are told, without using a calculator, determine 2 sine squared 77 degrees in terms of m. So in other words, the answer must have a m inside it. Well, how do we approach that? Very easy. There are 2 methods. I'll show you them. Firstly, 2 sine squared 77. We need to find that. Can be written as 2 square brackets. We need to recognize that the number 77 is 90 degrees minus 13. Not so? I'm sure you agree with that. And we square that. Then, from that, we bring the 2 down. The sine of 90 minus theta is actually the cosine of theta. And so we have cosine of 13 degrees, but when we square that, we're going to have 2 cosine squared 13 degrees. And once again, this is in identity format. So now we write that as 2 cosine squared 13 degrees minus 1 plus 1, and this will bring us to cosine 26, which we know is the value of m. They told us that, and there we have plus 1. Or we could also say 1 minus 2 sine squared 77 degrees is equal to the cosine of 154 degrees. If we have to take this one over, let's put it like that, or maybe even take this one over and bring this one across, we're going to have 2 sine squared 77 degrees is equal to 1 minus cosine of 154 degrees. Now we know that this angle is in the second quadrant, and cosine in the second quadrant is negative. Hence, in brackets, I have minus 26, because 26 plus 154 will give me 180 degrees. And therefore, 1 minus cosine 26, I'm going to have a positive here, and I'm going to have 1 plus m, which is the same as m plus 1. Let me now have a look at question 5.4. The last question in this particular question in the paper 2 of November 2019. And this involved general solutions. But what this question actually called upon us to do is we had to just step back and try and see the vision of the big picture in terms of trigonometric identities. Remember the 3-point plan. Simplify, factorize, identities. SFI. Grade 12s, if on your paper you write those 3 points down as a memory guide, you will do very, very well with your trigonometry. In fact, you'll be able to solve almost anything. Let's now have a look at this last question. Question 5.4 says, consider f of x is equal to sine x plus 25 cosine 15 degrees minus cosine x plus 25 minus multiplied by sine of 15 degrees. What we need to do at this juncture is to recognize that here we have an identity that is lurking in an interesting format. Can you see that this looks like the sine of alpha minus beta formula, right? So then we are told, determine the general solution of that if that is equal to the tangent of 165 degrees. Now we know that 165 degrees is in the second quadrant. So we can expect to get a negative answer because in the second quadrant, tangent is negative. Remember, the defining angle ratio of the second quadrant is 180 degrees minus theta. And the only trigonometric ratio that is positive in the second quadrant is sine. So tangent is negative. So how do we approach this? Well, when we look to our solution, there we have it. We start off by writing the left-hand side as sine of x plus 25 degrees, cosine 15 degrees, minus cosine x plus 25, sine of 15 degrees is equal to 165. Now, when we simplify this using the identities, we have the sine of x plus 25 minus 15 degrees. That's on our left-hand side. And then if on our calculator, we can use a calculator for this now. They didn't say we can't, so we have to use it. We get an answer either of minus, remember I told you it's going to be minus, 0,2679, or we have minus 2 plus root 3. When we simplify this, 25 minus 15 is going to give us the sine of x plus 10, and we have minus 0,267. Now we launch forth using the general solution formulae. The general solution for sine indicates the following. Here we have our reference angle. Now remember, we have to use on the calculator the positive of this, right? You learned that in grade 11. You can't use the negative. You use the positive value, and then we get a value, right? So there we have x plus 10 degrees is equal to 195,54 degrees plus k 360. And when we take the 10 over, it becomes negative. We subtract it from that figure. One part of our solution will be x is equal to 185,54 degrees plus k dot 360 degrees, where k is an element of z, or element of integers. Don't forget that. The second one, we know that because it's negative there, right? It's going to be in the third quadrant. So we take that across and we move it across there, right? And we take it across that side, and there we have our solution here of x is equal to 334,460 degrees. That is in the fourth quadrant because that is where sine is negative. Sine is negative in the third quadrant as we see it here, 185 degrees because that's greater than 180 degrees. And the fourth quadrant, right? This is the fourth quadrant. X is equal to 334,460 degrees plus k 360. Very important. Now the final step after we found the general solution, the question says, determine the values of x in the interval. X is an element of 0 degrees plus, or 0 degrees semicolon 360 degrees, for which f of x will have a minimum value. Grade 12s. The sine graph, you may know, is a very interesting graph that looks something like this. If we have to draw a sine graph, the sine graph which we learned in grade 10 is drawn in this manner here. And I'm just going to take, that's right, we go up, we come down, and there we go, like that. Okay, and I'll just extend my x-axis. There we go. Right. This is 0 degrees. And then this one here, where it peaks at 1, and this is minus 1, right? This here, we learned, is 90 degrees. This is 180 degrees. And this minimum value, notice the minimum value, minus 1 here is 270 degrees, right? And that's 360 degrees. The question says, determine the value or values of x in the interval for which that will have a minimum value. Notice I am given a domain of 0 degrees to 360 degrees. So I'm not concerned about this side of the graph. Well, that's very easy. I am told here that the minimum value at 270 degrees is minus 1. So, with this understanding in mind, notice how we solve this. F of x is equal to sine x plus 10 degrees, right? We know that. For the minimum value of sine x, the graph that I just drew, x is equal to 270 degrees. There we see it right here, 270 degrees. Therefore, for the minimum value, we take this, put it on the left-hand side there, and therefore, if we take the 10 over, it's going to be negative. So 270 degrees minus 10 degrees, x will be 260 degrees. That is our solution. So what have we been saying in our telematics broadcast for this afternoon? As we can see on the monitor, grade 12s, practice, practice, practice. Be guided by the motto, plan your work, then work your plan. You see, if we do that, when we do trigonometry, we need to follow the 3-point plan. Do you remember our 3-point plan? Simplify, factorize, identities being used. If you follow that, you will do very, very well in your trigonometry. Remember, trigonometry also involves trigonometric graphs. We have a telematics broadcast in that connection. Please review that. Trigonometry also involves 2D and 3D trigonometry. We have a broadcast in that connection as well. Please review that as well. We wish you well as you prepare for your final examinations, grade 12. Remember, don't give up, don't give in. All the best and keep working on your mathematics. From all of us here in the telematics studio, bye-bye.